Hello everyone. In this session, we will discuss about the peak detector. Here, if you observe the title, peak means the maximum value, detector, it will give the peak value simply. So, name itself, it gives peak value of waveform, peak value of signal or waveform. Okay, yes. For example, if in order to get the peak detector, we required only a diode and with respect to a capacitor, then we will get the peak value. Then, so this is a general peak detector. If you are giving the input signal is some non-sinusoidal or non-linear signal is there, that is signal is modified like this. So in order to get the peak value from the for the signal, so we have to give this input. So this is the positive side signal, that's why it is forward biased. Then capacitor is, this is the output voltage. So generally the output voltage is the output across the capacitor will store the voltage. And after that, what happen, the input signal will be decreases means this voltage is high value and this voltage is low value, then it is reverse biased, there is no diode on. That's why this voltage value is fixed, because capacitor stores the voltage, because that capacitor doesn't have any path. So for example, just look at here. So in this case, initially up to this capacitor is stores like this. Initially capacitor is stores like this. This is the V0 voltage and this is the Vi voltage. Up to this value is fixed. After input value this value is maximum value, then this value, for example, take it as the V1. For example, this is the V1 and this Vi is less than V1, then it become the open. Then capacitor has some value, it is a fixed value, there is no path to supply the current, so the output is fixed only up to this point. After this capacitor again charging, after this capacitor value is fixed. So then the voltage across the capacitor will show the peak value. The voltage across the capacitor will show the peak value. So by using the capacitor as well as diode, we can detect the peak value from the given input signal. Okay, so for this peak detector, if we are using the op-amp, so in order to get the peak detector, if we are using the op-amp, then the peak detector is become active peak detector, that is become the active peak detector. So here the we will collect the voltage and we will given some load, that is the RL, which is connected across a capacitor, and there is some diode 1 is there, and here the diode 2 is for to avoid the negative saturation, and these are the two resistors, and input is given to the non-inverting terminal. For example, if we are giving the input is the square wave, for example, if we are giving the input is the square wave, then how we'll detect the peak will be explained here. The square wave is like this. The square wave is like this. So this is the square wave input voltage. So for this, how it acts? So for this particular condition, the input is the square wave. This is the positive value. Here also we will get the positive value, and for the positive value diode will be on, diode will be shorted, and the total voltage will be, capacitor is the output voltage, we will get the capacitor voltage. That voltage is maybe the saturation voltage or the peak voltage. So it will reach the peak voltage. So it will reach the peak voltage is like this, then the voltage is become like this, So the voltage may be slightly slowly increases and charging it will reach the peak value. So after negative supply, the what happen? If the supply is negative, then the voltage you are getting is negative. Then here it will be open, it will be off. Then there is no power. There is no power is entering. So that time the total power will be distributed like this. Then the total current will be flow like this, and capacitor itself having the voltage and it doesn't have any path because resistor value is high. Here the resistor is very high, acts as a buffer circuit. So there is no path for the capacitor. Almost capacitor value is fixed and maybe slightly decreases. So after positive voltage it will again increases, negative voltage again decreases. So these values are the peak values, are the maximum values. Peak values are the maximum values. So we will write some statement here, that is for positive half cycle, for positive half cycle what happened? Diode 1 is on, D1 is on and D2 is off, and here the D2 in off position. And here in this condition capacitor is charging, fully charging. And for negative half cycle what happened? For the negative half cycle D1 is off, D1 is off and D2 is on, and capacitor doesn't have any path. VC value is fixed, previous value fixed, because it has high load resistance, high RL as well as R. So whenever the high resistance is there, then automatically there is no path and there is no path. Okay, so no path for the current, no path for current. Okay, so then what is the reason for providing the D2? If there is no D2, what happened? Here the negative is there, here the positive is there. After some time what happened? After some time it will come to here and negative saturation will be occur, then it become the minus V saturation. In order to avoid that, so D2 is to avoid negative saturation, to avoid negative saturation. Okay, so this is the working of the active peak detector, active peak detector. Okay, once again peak detector. So look at here, in this value peak value, this is the value, and in this value this is the peak value, this is the peak value. So these are the peak values. Okay, so this is the working of the active peak detector. Okay, okay, next topic is monoshot. So monoshot is nothing but the monostable multivibrator. And what is the meaning of the mono? Mono means simply single stable state. Mono means single stable state. Monostable means single stable state. It has only one stable state. If you give the any input, it has only one stable state. That is called the monostable state. So how it is working? We should look at here. Here, if we are giving, if it produces some output, that output is between the, generally for the multivibrator the output is between the positive saturation and the negative saturation. So the output is like this. For example, initially there is no output, the output will produce like this. The output is plus V saturation and the minus V saturation in between plus V saturation and the minus V saturation. Okay, this is the beta saturation, beta into V saturation, and this is the minus beta into V saturation. These are also having some limits. It is the internal circuit, there is no need of the thinking. Okay, for example, if at the V saturation, what happen? For example, for the V saturation, if it produces the output voltage is here V saturation, what happen? Then the current across V1, then plus V saturation means this is the positive voltage, and the positive voltage means here it will flow from the ground. The capacitor voltage is very low, so that's why I can write the capacitor voltage has less drop. This is the 0.7 volts. We can take it as this is the capacitor voltage. And if the input is given some negative voltage, for example, if the input is given some negative voltage, what happened? Here the negative voltage and here the negative voltage. Here whenever this is negative voltage and this is the positive voltage, automatically it will generate the V saturation. So that is it will generate some minus V saturation voltage. For up to what? Here the minus V saturation, whenever it is minus V saturation, so this is the negative, this is also the negative, then it will negatively charged, then it will be negatively charged, and up to which, so it is negatively charged, so slowly Vc value negatively charged, at which point it will more than the positive value, positive negative charging, then automatically it will change the stable state system. It will change, it will insert from the negative to again positive, and it will continuously going. It will continuously going. Okay, why? Here negative is dominant. It is more negative compared with this negative. Then automatically it will generate the plus V saturation. So that's why although you are giving the input value is the negative, then automatically after some time it will become into the positive values. After some time it will become into the positive value. Then again it will be increases. It will follows like this. This is the VC voltage and this is the output voltage, and here it itself. So we can write one statement. That statement is, although if you give any input, the output will become previous state. That is, it has only one stable state. So that is called the monostable system or the monoshot. Monostable system and monoshot. So we can write the time period of the monostable system is like this. Time period T equaled RC into log 1 plus R2 by R1. So this is R into C. R is the resistor, C is the capacitor, and this is R2 by R1. Generally, this R1, R2 are the voltage divider networks. This R is the feedback resistor, and C is the voltage applied across the inverting terminal. So this is the thing. Okay, yeah. So we can write two statements, that is how it working for positive half cycle as well as negative half cycle. For positive input, what will work? So D will be on. Capacitor have low voltage drop, because whenever the diode is on, the total current will flow through that only. And for negative half cycle, for negative input, here the D is become off, then capacitor is negatively charged. Okay, so whenever the V input is greater than VC, then automatically output is become the plus V saturation plus V saturation. So by using that, monostable vibrator will be working. Okay, this is about how the monoshot will be worked the using the operational amplifier. Okay, next is the 555 timer. This is the last application of our operational amplifier. Here 555 timer is very much useful. It doesn't have more and more applications. So first we look at the applications. So this 555 timer is useful for the tone and alarm generations. So generally, in order to use the alarm, we are using this 555 timer. And frequency division. So in order to divide the frequencies, it should be useful. And third is it provides time delay. Generally, in order to get the time delays circuits, the circuit will be provided by the 555 timer. Next, relaxation oscillator. So it will be applicable in the relaxation oscillator also. So first, look at the pin diagram. So look at the pin diagram here. Here the 555 timer having 8 pins, consisting of the 8 pins. Here the first pin is working as a ground. So pin means inside it has a circuit. It has the number of circuits and number of elements, but in order to give the connections easily, we are assigning some pins. That by identifying the pins, by using the pins, we can give the connections. We can analyze the circuit easily. The second pin is for trigger. Triggering means, so if it have some thyristors or some BJTs, it will give triggering from here this pin. Third will output. So we will collect output from this point. And fourth is the reset pin. Reset pin is useful. If you click the reset pin, the output is almost zero. The output is almost zero. Okay. And next, fifth, control switch. So we have the control pin is there. In order to control the 555 timer, the pin will be useful. Sixth is the threshold pin. So in order to operate this 555 timer, minimum value is required. That is the threshold pin. Next is the discharge pin. So this pin is useful for discharging. And last pin is the VCC. VCC is nothing but it's a supply pin. We can call it as the supply pin. And we will again discuss the each and every pin after completion of this. So generally, so we are discussing about the number of pins. The pins connection is like this. So this is the internal diagram of the 555 timer. Look at here. There is the two operational amplifiers. We will use the two operational amplifiers. These two operational amplifiers will be worked as comparators. Will be worked as the comparators. Okay. Yeah. Here in these comparators will be given two inputs, and we are given the two things, two inputs, 2 and 6. First is the ground terminal. You know that what is the two value is trigger. So we will give the triggering input here. And what is the 6 value? 6 value is a threshold value. So it will take the trigger value, it will threshold the value, and take the help from the 8 and 5. What is 8? 8 is the VCC. So this is the supply voltage. Supply voltage is given, apply to this. Then it will generate the drop across these resistors. And next to fifth is nothing but here control. So we can control by using this pin, we can control the voltage, and the output from this comparator will be given to the flip-flops. So these are the flip-flops, these are the switching devices. Now after that, output will be given to the transistor is there. The transistor is given from the discharge. So we are generally given the discharge is here. So after the discharge, we will get the output here. We will get the output here, and this third point is the output. This third point is the output. So we can give some values to this each and every pin. So those values are, so we can write first pin. You know the first pin already right, and ground is there. Okay, so you know this is the ground already, and This ground is nothing but simply a circuit ground. Circuit completely grounded from this switch. Okay. What about second and sixth pins? Here second and sixth two pins are there. These are, second pin is the threshold pin and sixth pin is the triggering pin. And we can simply call it as inputs. Why it is called as inputs? Look at here. So these two are acting as inputs for the circuit. Okay. And so by changing the inputs, we can vary the output also. So by changing the inputs, the output can be varied. Okay. And next, third, so we will collect the output from this point. Look at here. This is the output. So what is the output here generally? The output is, and we will get the 200 milliamperes of load current from the to the output side. Okay. Yeah. Here we have again two pins are available. Those are A and B. A and B. So generally if you observe here, these all are the equal drops. So directly we can write the A is, we can take it as the some reference node. A is call it as some reference node. Generally it has 2 by 3 times of VCC. Why it VCC? VCC 8th pin is the supply. It will be supplied from this here. And B is directly we can write the this is also a reference, and we can directly write the 1 by 3 VCC. Okay. Yes. And so this is the voltage drops. By using these voltage drops, the comparators will be worked here. Comparators will be worked here. Okay. Yeah. So by using this circuit, so you will get each and everything of the flip-flops in the next topic. But this is the internal block diagram of the 555 timer. So in the 555 timer construction, op amps will be used like this. It will be works as comparators. Okay. Yeah. So about the flip-flops you will understand in the digital electronics. So now it is very difficult to understand, and you know about the transistors, and the working is also not required. And so this is about the 555 timer. Okay. I hope all of you understand the session. Thank you.